Mateusz Wroblewski. I'm from Poland, from a company called 11-Bit Studios. Maybe you heard it or not. Currently, I'm an engine programmer, but I used to be lead AI programmer in the Frostpunk and very many various roles of programmer during my 7th-year stay there. I'd like to share some experiences with you of how to support gameplay programming from the engine side. So we'll learn how to keep our growing gameplay codebase in check. First of all, what's this talk about? Well, I didn't want to do any kind of a programming tutorial because, obviously you would fall asleep, so I just kept my code to a minimum. Maybe it's worth asking, how many of you here are actually programmers? Oh, okay. This gives me a minute that I won't have to go into the details very much. Second, I think that knowledge about bad solutions sometimes equally important as knowledge about the good solutions, because we often have to make some errors to know the value of some concepts. And just let me save you some time and introduce you to some bad concepts, then show you good concepts, so you can learn from our errors. This talk is about our evolution of game programming, because all of our titles that we've shipped comes from our own, are based on our own technology called Liquid Engine. So a few years ago, we released titles like Anomaly series and a few other smaller games. Then we had This World of Mine. It was our first big success. And last but not least, there was Frostpunk. And of course, we have plans for the future. So, what's the area of interest? If you imagine how the game engine looks like, at the bottom there's the engine core. So there's the mathematics there, memory management, and so on and so on. Above that, there are engine assets. So managing every of your file from the engine, right? And then we have systems like render, physics, audio, and so on. Above that, there's the area of interest. This sometimes people call it gameplay foundations. Is the supportive layer of the engine that is used by the gameplay programmers to program their game or prototype it as fast as possible. So in this area we'll have scripting, game object model, so the base representation of every entity in the game, entity component system that we'll talk about it later, and we've got something that I call events. We call events for communicating in our system, in our game. And for that, of course, we build the gameplay. What's the plan? Well, why do we even bother with components? Unity has components, Unreal has components, most modern game engines have components. Then we'll talk about anti-component system architecture versus component-based architecture. What are the caveats of each of them? And then we'll talk about how we realized our event system in our engine. And last point, I'll give you some case study of how did we do gameplay time-lapse capturing in Frostpunk. So, why bother with components? Let's give a simple example. Suppose that we are trying to make a game without using components. Obviously, we'll have some base kind of our in-game object description, right? It will be some kind of game entity class. It will have some base properties because we want to position it somewhere in the world, so it will have position, rotation, scale, and obviously we want to display it, so it will have some kind of mesh. These are the base properties of our entity. Now, we are making maybe a strategy game or maybe a city builder game, so probably we'll have two subtypes of this entity. One of it will be character entity, which additionally will have AI support, the other will be building, so the characters can enter it. Okay, so far so good. Now the designer comes to the programmer and says, I would like to have a health bar, because characters can be killed and building can be destructed in our game. Okay, so let's place the property of hit points in the base class, because why not? But then we want to have something like maybe terrain entity, which is obviously indestructible, right? We don't want to see a health bar above the terrain entity, because it's used only for visuals or collisions. The programmer says, okay, I'll fix that. I'll just give a destructible switch in the main class, and a subclasses say, okay, character is destructible, building entity is destructible, terrain entity is not destructible. Okay, so far so good. But now, suppose that we want to add plane to the game. Now, what does a lazy programmer think? Oh, maybe lazy is not the right word. What does a clever programmer think? A clever programmer thinks, okay, so a plane is a kind of entity that characters can enter to, and it's also destructible, right? So it's almost the same as building, but it can fly. We want to reuse our code, right? Because we are lazy. I'm sorry, clever. So let's just make an inheritance. So it means that plane is a subtype of building? What? Every programmer that sees that will obviously say, hey dude, this is a hack. Okay, but I didn't have time for this. So let's refactor this. We'll just move the common functionality to a base class. This will be an interface, place for characters interface. We don't say if it's plane, if it's building, and we just give it the subtypes. But still, what if a designer comes to us and says, dude, I would like to have a building that characters couldn't enter. You know, it will be a kind of a statue maybe. So we'll have to refactor it again and again and again. What's the solution? Well, the obvious solution is to take all those functionalities and make them truly independent by using the components. So in the components model, we've got only the base class, you know, so the system is working. And underneath we have independent location component. For instance, it have position, rotation, scale. We have render component from displaying. We have hit points component, turn component, place for characters component, stretcher component, and fly component. So we can realize the example that I've showed by using these components. If we imagine that we have to create three types of entities like character, like building, like turn for our game, maybe some others, that we have to, from now on, we have to imagine those kind of entities just like a containers. And in these containers, we'll be giving components. So character, because it's placed somewhere in the world, it needs location. It needs rendering because we'll be displaying it. It needs hit points because it's destructible, AI for the AI support, of course. Building. Location, it's obvious. Render. Hit points because it's destructible. Place for characters, so different kind of functionality. And structure component because, for instance, we want our citizens not to collide with it, right? And terrain, there's the location, render, and for instance, terrain component. Okay, so this is the basic explanation of why components. So components are kind of a building blocks for our entities. More about components. Well, what's good about components is that it realizes something that we call single responsibility paradigm. It's a very important feature when we are programming because we can define our programming model independently one from each other, so the functionalities are quite atomic. Second, it is really easy to add new functionalities and you'll end up with much less refactoring by using components. You'll have transparent configuration. If you see a toolbar anywhere in the game, you know it has HP component. And last, component can be divided in lesser components easily. For instance, if we had building component, if somewhere during development we've decided that we need some buildings that we can work in and some not, we can divide the building component to structure component, for instance, and workplace component. It just works. So we've said that in this model, entity can only be just a container for components. It's a pure component-based model, so it does not need subclassing. One of programmers in my company even said, go as further as that he said that we don't need an entity class, but just make it an entry like ID to some kind of table that will just hold a list of components. But I think it's too far. Just a base class entity as a container, maybe have some little properties like name or ID, and it's okay. The rest are made by components. There are various implementation of components. You'll find many approaches in internet. I'd like to introduce to you what worked for us. Now there's also this nice property that entity can have any set and any number of components, but usually the components are unique per entity. So for instance, if you're in our example, we'd like to create Superman, we would add a character fly component and remove HP component, and there we've got Superman. It's indestructible and it can fly. Just by reconfiguring components configuration. Now, one of the first games that we've developed that actually we started using components with Anomaly 2. It's not much happening in the game here except of the explosions. We have got towers, we've got some vehicles, each one shoot each other, we've got some abilities, and so on. This is quite a simple logic comparing to our other titles. We've got few vehicles, we've got one character that is steered by player, and we've got enemy towers. The maps are small, and we've got predefined roads that the player can take. This is our first approach to components, and they were implemented purely on the gameplay side. Let's leave that because it's not really important, just to show you our evolution. And our next game was This War of Mine. Well, there's more happening here. We've got characters that have their moods, their physics, their AI. We've got some elements that we can interact with. We can steer all the characters. So there's more complicated logic, but not many characters at once. At 10, I think is most. There are small separate scenes in this game. There are interactive objects with minimal UI attached to them. And the UI, as you can see, is minimalistic. Just a few entity types and systems to manage. So all those points make the game real simple to configure. Our latest title, Frostpunk. Oh, this is a much bigger game because we've got a lot of, happening. As you can see on the screen, we've got a giant generator in the middle that generates some heat. So we've got some heat system mechanics. We've got a lot of UIs that present a lot of data. We've got like few hundred citizens in the city. We've got some temperature mechanics, a lot of that. So it's our ambitions after This War of Mine made us make a bigger game. So we've got a lot of more AI agents, a lot of more buildings with different functions, much bigger scene. When we're talking about the scene, we're talking about the city that we see and the frostland that when we zoom out from the camera. We've got around 100 interactive object types, each of them has unique UI. And we've got a lot of systems and entities to manage. So the configuration of that is obviously complicated. When you compare those two games of how much we have to put work in it, we can see that obviously we had more gameplay programmers, we've got much bigger core dev team, and it took us almost two times more time to develop. But before I go further, how we did that in Frostpunk, how we did components Frostpunk, I'll have to tell you a bit about how did we do that in This War of Mine. So, let me introduce you to components in This War of Mine. Well, we've got a component-based architecture there, which means that we have a component which has data and logic operated on this data placed in it. It's quite easy to understand architecture. That was the most advantage of it, I think. Biggest advantage of it, I think. It was implemented on the gameplay side because at that time we didn't support it from the engine. And in this model, we are updating entities one after another. And when we are updating the entity, it updates all of its components. An example: if we have 3 characters in This War of Mine, when updates come and the game tick comes to update all of them, the first character is updated, its first component is updated, then second component, then third component, and so on, so on. If we updated all the components, we move on to the second character, we update his components, and so on and so on, and we move to the next character. That's obvious, okay? What does it mean? One more thing. How do we communicate between those characters? Oh no, it's a little bit of code. Sorry for that. I hope that it's not a very boring stuff, but just wanted to show that it was a very crude way of doing the communication in our game, because we just sent for instance, if you imagine one entity would like to shoot other entity, that it would send event to it, hey, change your hit points, and the other entity in the component would get the event and react on it. It was just passed by some kind of simple enum ID and some params which were very primitive casted to what we wanted to get from that. This is a really primitive way to do that. I'll show you better in a while. But now, knowing the knowledge of how the entities are updated and knowing how we are passing the events, let's imagine that we want to make this kind of game collision avoidance. How do we do that? Well, we want to do it in movement component. The first character comes and says his update comes to him, and he says, "Hey, is anyone nearby?" He sends this kind of event, and he sees that there is other character nearby. So he says, "Okay, in my computing, in my component, I'm recomputing my velocity vector." We had it updated, and then update comes to the next agent, and he asks the same question: "Is anyone nearby?" He finds the other agent, and he recomputes his velocity vector. Of course, what that means is that we do the same twice, or in this case, twice the same operations, right? So it's not very performant solution. It's not very elegant. So what we have to do, we have to add just, a kind of a global manager collision that will, scan the entities, will say which one entity is near one, and will update them one by one. Okay, but what we end up is a partial logic system, a partial logic which is placed in the system, the manager, and partial logic which is placed in the components. So it's not very nice solution. So it resulted in this of mine a case that we had a lot of global managers that were interacted with components, entities, global state. Well, this definition of a mess in the code, really. We had a lot of entities with independent mechanics, because one entity had to inform our entity about something. It wasn't really efficient. So if we wanted to use this mechanics in Frostpunk, well, it was going to blow. So what's the conclusion? We had to, if we were to make a bigger game than this war of mine, we need better architecture. That would be supported in the engine from the very start. Our solution? Entity component systems. So what is an entity component system? It's a variation of components. For me, it's an upgrade. In this model, entity is still just a container for components. Component now keeps only the data and state for the single functionality, and the logic is moved to the system. And the changes to this data and kept in the component can be made only through system. Now the system operates on specific declared type or types of components, so it has access to the data, and it can keep some kind of a global state. So you can imagine that now collision avoidance could be made in a really more elegant way. Example of how we update this. If we now had this word of mine, for instance, and we had 3 characters, each of them a container for components, then update would go like this. First we update location component of first character, the second character, the last character, and then we go to the update of the next functionality. So we are updating render, for instance, then we go to the next functionality, update some hit points, next functionality, update AI, next functionality, movement component. So it is a kind of horizontal update. What does it give it to us? Well, first of all, because the entity component system, we don't have loosely coupled managers with the components anymore. We can update per functionality, not per entity. As a consequence, it's much easier for multi-threading if you get a lot of happening on the scene. Multi-threading is the only solution, to make the game playable. Unfortunately, in Frostpunk we couldn't really make it because we are too far in the development and we already had some dependencies between the systems. It's a quite complicated topic of synchronization. And the last advantage is that there are possible, last but not least maybe, there are possible memory caching optimizations, because when we are updating it horizontally, we can put in the memory all the components right next to each other, so our central processing unit will really like it when he goes from updates from near memory accesses. What does also entity component system gives us is that there's a clear system responsibility and communication, because we know what each system does. How to implement it? Or simply, if we have an entity, it has to register its list of component to interested systems. System must keep a list of pairs of entity and component which were registered to it. Now many systems can operate on one component type, so for instance we can have building component and a building system that manages those buildings, but you can also have a construction system which also works on a building component for managing construction. And system can operate on more than one component types, which is useful because we can have collision system that operates on movement component and collision component, and then it will work as a charm. What is Frostpunk specifics for our entity component system? Well, first of all, we simplified it a bit. The system can declare only on one component type. I think that we've regretted it at the end of the development, but I wouldn't say that was a bad decision. Okay, maybe it worked for us better, maybe not. Depends on the game and the team. We made the systems to be global and easily accessible, so we had the global pointers for every system. The order at which we updated all those systems did have meaning. So it meant that the programmer, when he created a new system, he had to be very careful where would he place it in the queue of the updates. And we really discouraged using inheritance in components or systems. So now, after we've released the Frostpunk, we've come to some conclusions of how can we upgrade the system. Well, first of all, we decided that we really should ban using all the global pointers to our entity component systems. So we don't want to use something like the first line, but we want to use more like something in the second line. The second thing to update is that it will only work if we declare dependencies in every system. So for instance, if we have movement system, somewhere during the initialization, we'll just declare the dependency on the collision system. The last thing is to draw assertion in system that every time we could try to call another system that we didn't declare. So we have method getSystem, template method getSystem in one of our systems. We check if we've declared the system, and then we retrieving the system from the global manager. So it will work like that. If during the update we are accessing collision system that we have declared, the collision, it will be okay, the assertion will be okay, but if later on we'll use, for instance, animation system, the assertion will fail because we didn't declare it here. Okay, so far so good. What's the result of those upgrades? Well, now order of updates can be established under the hood. We know all the dependencies, which system depends on what, so we can program it in the engine side so that the updates will be obvious. Synchronization to do is much easier, which is important. And there are transport code dependencies because we can clearly see which system is waiting for which system. That's the most of the advantages. So the next point, events. We have entity component systems. We need to communicate between them, right? Well, we've implemented something that equals to C# delegate mechanisms. We've used some templates, function pointers, and parameters forwarding, and some C++ magic to do something like this. We can declare event in one kind of a system with declaring the explicitly declaring parameters that we'll be building, it will be building component, and then we could receive it on the other side, for instance in work system, by declaring that I'm interested in receiving those kind of events, and it worked. We just have written a function that would react on the construction finished event, and we did some things with it. But in this model, we avoided global loose events. So every event was, assigned to a kind of a system. Then we know which functionality it has. We had supervisor helper class to avoid cycles because one event could be sent, and in response, other event can be sent that would call the first event. So we have infinite loop. We allowed to have some public methods in systems. So if we have, for instance, when we have two systems that are somehow coupled with each other, okay, we allowed to, call each other's methods because it was easier and simplified the code, and obviously the calling of the functions is faster than sending an events. Okay, now the question for you. How many of you did play Frostpunk? Oh, a lot of guys. Okay, so have you reached the time lapse at the end of that? Probably yes, some of you. Okay. Can we play the movie that is attached to this? Because I couldn't embed it here, I think. But if it's a problem, we'll omit it. But I'd like to show you just the time lapse, so the functionality that we've made. Oh, it's a problem? Oh, okay. So I'll show the time lapse. Some of you probably seen it or probably not. But it was a kind of functionality that at the end of the game, when you finish the scenario, you would see your game's progress. So you would see where did you put the buildings, where were the citizens at the time, what was the weather like, what was the time of the day, and so on and so on. This time lapse was like, I don't know, 2 minutes long maybe, and it tracked all of your game's achievements. It also gave you some summarization of what happened during the game and what kind of decision did you make. Now, this feature was added very late during the development. We decided to add it, and we had to decide how to do this. Well, first of all, we did that as entity component systems. Well, obviously, taking screenshots during the game is obviously not an option, right? Because first of all, it would take like a few gigabytes of memory, seconds. We would have to render all the scene from different point of view, and you can do that when you have really tight rendering with a lot of features. So the goal was to write it on the engine side with minimum setup in Frostpunk, just to not to blow the game during the latest stage of development. It was like 2 or 3 months before the game release. We tried very hard not to blow the save game files. So if you played Frostpunk and you've seen that your save files have like 300 megabytes, now you know why. It's because of the time-lapse capturing. It was a big feature, there was little time for it. So how did we implement it? First, we decided that we'll use entity component system to track the entity state changes. We decided that each configured time interval will take a snapshot of every entity state. But now, we wouldn't save the exact state of the entity, we'll just save changes, just to save space. So for instance, if the location of an entity during the snapshots did not change, then we would save nothing to the snapshot. Because if you have buildings, then just they are placed probably somewhere on the beginning of the game, and then nothing changes with that, so we don't save it. But still, how did we reach 200 or 300 megabytes of our saves? If it's this kind of brilliant optimization that I'm talking about. Well, there are some custom things in Frostpunk that we also had to include. One of them was the streets model, which was a custom for Frostpunk. The other was snow. So obviously, now you know that in your saves, if you have 200 or 300 megabytes, most of those informations are the snow changes. Sorry. We could optimize it a bit, but we wanted it, to look really good when all those citizens are walking and they're making all those paths in the snow. And besides of that, we didn't really have much time, as I've already said, to optimize it. So still, 300 megabytes were acceptable. So here we have a little bit of code. Hope you don't sleep. We've declared some kind of the time-lapse capture component, of course we needed, where we had some entity capture state kept. And the capture state is just, position, rotation, and so on. After having this component, we had, of course, time-lapse capture system which was operating on it. In the time-lapse capture system initialization, we were listening to the events of entity manager, which sends event each time the new entity was created. We didn't need information about entity removed from the entity manager. I will tell you why in a minute. And when we detected that a new entity is created, first we checked if we are interested in capturing the state of that entity, and then what did we do? We just added component, timelapse capture component to this entity. So we had no idea about anything about the gameplay from the engine side. We could just, by using components, we could inject some functionality to the entity, and the entity itself in the game didn't know that it has its state captured because of that. So it's a really nice property of entity com systems that can do such things. Now, when we detected that the entity was added, in our entity com system we have two methods that are called each time we add an entity to the system or remove it from it. So we have entity added. This is some kind of a method, and when we've detected that it was added, we add the entity to recently created entities list. When the entity was removed, first we needed to check something, because if we take one snapshot, if we take second snapshot, and during that time entity was created and removed before the second snapshot changed, we don't need to track it because nothing happened there, and during the snapshot it won't be visible. So we removed only it from if we manage to catch the situation. Okay, so the last thing to know is the simplification of how the snapshot was taken. Of course, when the game calls the method take snapshot from our engine, we create new snapshot, add it to the current timelapse timeline. In the snapshot, we tell which entities were created recently, and then we clear that list because obviously we've just passed the information to the snapshot. We don't need it anymore. Of course, for those of you acquainted with the C++ move semantics, it would be more elegant just to use std move of this list, but for the clarity, I present it like that. Of course, we also have to table a snapshot that during this time that happened, we've removed some entities, so we do the same that we've added. And the last thing, we are iterating all the entities from this system to save the state differences. It's a convenient method that we can get pair of entity and timelapse capture component, and then just write state changes to the snapshot. And that was all. So the timelapse playback was pretty easy. We didn't need components for that because we just decided that we can change the state based on the snapshot and that's all. And when we requested the timelapse to be playback, went to separate state where there's no game logic. So even if you created an entity that had AI component, it doesn't mean that it will be run because we didn't create the system that's responsible for running it. So in the game state, no one ever knows that there's an entity with the game component. So to sum up, I must point here that this is our point of view. For us, components are way better in game programming than inheritance. But maybe for you, something other will work. Maybe you have a simple game in which you just have like 3 entity types. Well, maybe go for inheritance. Don't bother with components. Maybe so. It'll work for you. For us, entity component system approach, so the approach where we separate the data from the logic operating on it, is much better than component-based architecture. You need to also keep in mind the communication between systems, how you realize it. Events are very nice, but keep in mind that you can also just call the public methods of the systems, but don't change the data from the component from the system that is not in any way connected with the component. Clean architecture can really save the development time and really make some features without blowing everything up that we've done and without to refactor it. So I think that's all. Thank you very much for your attention. Now if you want to contact me, there's the email, and maybe we have still some time for questions, right?
Yes, we do. So, do we have some questions? Yes, please. Yeah, the lady is coming and she will give you a microphone.
Hi.
Hi.
Thank you for sharing those details.
Welcome.
Looking at the final architecture, so after all the optimizations, all the things you did better from the architecture point of view, what is the one that took you the most, the longer to figure out until you were happy with the result? Like, what was the most painful part of the architecture?
Well, I think that I didn't go into the details of the how we implemented entity component systems because obviously it would be boring for non-programmers, but I think that the most difficult thing was to just, make the templating of the C++ right. So then if you have a system, like movement system, then inside you have some template function variations that you can declare that you want to operate on movement components in the class declaration just by using the inheritance with the proper template argument, and then thanks to it you could just use in your movement system get component without anything, and you would know that it will be a proper movement component. Then there were things like keeping in mind when to pass the events, like that entity was added, entity was removed, because for instance what to do when you are loading the game. Should you also inform that the entity was added because you've just created an entity from the save game? So we had to do some basic stuff with making this thing elegant. So I think that the templating and also keeping the right state of the when entity was really created and when it was just restored.
And it came mostly from back and forth between gameplay and engine programmers, or it was like one of them was leading the discussion?
When we are doing this, we're prototyping Frostpunk, and during that time I was sitting still in the gameplay of Frostpunk, and there was only two programmers doing the prototyping, me and my colleague Marcin, and we decided that okay, we need to do this properly because we've already done some prototyping on this War of Mine system, and I decided no, it's gonna blow for us. So we've contacted the engine team. Guys, we would like to do some mess with the engine. Can we? Okay, we've got separate branch for it. Do your magic. So we started developing the system before we actually developed the game or the prototype. So we had some proof of concept that it really works during the prototype. When we are actually comfortable with the result, we said okay, it's okay. But still, during the development, we decided we don't need multiple component types in our system because it complicates the code, so we changed the architecture. Nowadays, when I'm in engine team and the engine team is bigger, gameplay often goes to us and says, okay, guys, could you change something in the work? How does components work? Because we need some other functionalities. And we just modify it. This is the main advantage of having your own technology, that you can change it during the game development. Okay, any other questions?
So if I understood correctly, your systems handle only one type of component, right? So how did you manage to make a game with such a big limitation in my eyes? I mean, I think that most of the systems would care about such thing like health of some object.
Of course, in your example, if I have a weapon system that does damage and I have health system that operates on health component, I would do like that from my weapon system, I would either send an event that the entity was shot, so I would like to change its hit points, or just don't even say that I want to change hit points. I would just say the entity was shot and base damage is like 100. On this event, the HAPA system would react because it would, subscribe for the event from the weapon system and would say, I would like to know each time that the event of damaging was sent. The HP system would react and it would, just lower the health of in the health component, the component that it holds by 100 and so on, decide if it should be dead or not. So now the weapon system does not have to have knowledge of the HP component. You could send events about damaging the entity, and if the entity did not have HP component, then no one would respond it, right? And then you have a Superman, basically. Other solution If we have only, one receiver of this event kind of damage, we can just, use, as I said, public methods. So our weapon system can call the method in HP system, hey, damage this entity, and we pass the entity. The HP system checks if it really has the component, HP component, if it is really this entity belongs to us, because we can check it. And if it belongs to it, it accesses the HP component and lowers the health.